In this video, I am going to explain some examples of the binomial distribution. Here, I will be explaining how to find the probabilities of binomial random variables. First, W has binomial distribution n equal 50 and success probability is 0.12. Find the probability W greater than 2. First, let me write down the information we know here. N equal 50, success probability equal 0.12. Then what are the values of W? N equal 50, therefore W goes from 0 to 50. Now find the probability W greater than 2. So can we use this equation directly? No, we cannot use this equation directly. Why? But here we see that it is equal sign, but here greater than sign. Therefore, we have to write this one with equal sign. How do we write this with equal sign? You know W is binomial, therefore this is the discrete random variable. Therefore, we can write this W greater than or equal 3 because greater than 2 means greater than or equal 3. If you apply the discrete property here, you can write this one W equal 3 plus probability of W equal 4 up to probability of W equal 50. Because N equal 50, W can take 0 to 50. But this is hard to simplify one by one. Why? We have to apply this formula mass function for each of these. For the W equal 3, W equal 4, so on until you get W equal 50. Therefore, we should use the easy way to find the probability. How do we do that? You know, using the properties of probabilities of the discrete case, we can write this one 1 minus probability W less than or equal to. Right. Therefore, now we can write probability W less than or equal to mean W equals 0 plus probability of W equal 1 plus probability of W equal 2. So now you can apply mass function for each of them. So let me explain 1 minus here probability W equals 0. N equal 50, 50 choose 0. Then P is 0.12. The power 0. 1 minus 0.12 power 50 minus 0. That is for the W equals 0. Then plus. Then W equal 1. How do we find the probability for W equal 1? 50 choose 1. 0.12 to power 1. 1 minus 0.12 power 50 minus 1. Then the last one, probability W equal to 50 choose 2 times 0.12 to power 2, 1 minus 0.12, 50 minus 2. Then we can simplify this and you can have 0.94874. Again, understand this. Here W is the binomial, therefore it is a discrete random variable. Therefore, you can apply this rule for the discrete case. Here greater than 2, therefore less than or equal to. Then we separate this like this, and then you have here equal sign. You see that? So you can apply this mass function for each of them. Next example. Hospital records show that of patients suffering from a certain disease, 75% die of it. What is the probability that of 6 randomly selected patients, 4 will recover? First, take the random variable. What is the random variable here? I use x. X is, here you see asking 4 will recover. Therefore, I take x number of people recover. Then I need to identify the distribution of x. What is the distribution of x? Here we see there are two outcomes. What are those? Recover or die. So it might be a binomial distribution. To make sure it is binomial, we need to check the four conditions. What is the first condition? The experiment consists of a fixed number n of identical trials. What is the n here? In this problem, we consider only 6 randomly selected patients. Therefore, n equals 6. Then, second condition, possible outcomes for each trial, success and failure. Okay, how many outcomes here? Here two outcomes, right? Die or recover. Therefore, two outcome, it is also satisfied. But what is the success? Yeah, let me explain it in the last condition. Now, third one, trials are independent. Yes, the patient are independent, right? They independently die or recover. Then the last one, the success probability we use P is the same for each trial. Okay, what is the success probability here? We are looking for the recover, recover people, right? But we have here 75% of die. So this is not the success probability. What is the success probability? Opposite of this, recover people. Then what is the probability of people recover? 1 because died 75%. Therefore, we can say 100 minus 75, 25%. Or we can say 0.25. That is the success probability. All four conditions are satisfied. Therefore, we can say x is the binomial distribution. If so, what is the parameter? What are the parameters? X has binomial distribution n equals 6 and success probability is 0.25. Then asking probability of x equal 4. Why? By asking what probability of 4 recover. Okay, 4 recover. Therefore, we can use this one binomial mass function n equals 6, k equal here what? This is the k, right? K equal 4, 6 choose 4, then p equal 0.25 and k equal 4, 1 minus 0.25, n equal 6 minus 4, n minus k. Again, understand what are the x values. What are the x values or what are the k values can take for this example. N equals 6, therefore x can take 0, 1 to 6. Right, then 6 factorial, 4 factorial, 2 factorial, and this is 0.25 power 4, and this is 0.75. 6 minus 4 is 2, right? So this is 0.033. That is the probability of 4 recover. If I ask find the probability at least 4 recover, what is the meaning of at least 4 recover? That means x can be 4, 5 and 6, at least 4 recover. Then how do we find this probability? Probability x greater than or equal 4, that is the at least 4 recover. Then this equal, how do we write? This is discrete random variable because of binomial, and also we cannot apply this mass function directly. Why? Here equal sign, here greater than or equal sign. Therefore, we need to write this as an equal sign. How do we do that? This equal probability x equal 4 plus probability x equal 5 plus probability x equal 6. Then you can apply the probability mass function formula for each of them. Here first one k equal 4, second one k equal 5, third one k equal 6. So you can do this one by yourself.